SpaceX's ferocious obsession with rewriting aerospace rules is what makes it untouchable, and the Raptor engine saga is proof. Forget Raptor 1 or 2, SpaceX obliterated limits with Raptor 3, and now they're unleashing the beastly Raptor 4, the most earth-shaking version yet. So what's this monster engine got in store? Buckle up, because the biggest leap is raw, unhinged power. I'm David, joined by the Starship Mission Update team, and we're ripping into the details right now. Raptor 4 represents a significant leap forward in rocket engine performance, particularly in terms of thrust, efficiency, and design refinement. Elon Musk noted in late 2024 that the Raptor 3.X series could achieve 300 tons of thrust at liftoff, which, by the way, is 3 times what the Saturn V's legendary F1 engine produced. However, during an interview with Everyday Astronaut, Musk mentioned a more advanced version capable of reaching 330 tons, which likely refers to Raptor 4. This output marks an approximate 17% increase over Raptor 3's standard 280-ton thrust, and a remarkable 43% increase compared to Raptor 2. If SpaceX maintains the current Starship and Super Heavy configuration, this improvement could enable the booster to deliver up to 10,890 tons of thrust at liftoff. Beyond raw power, efficiency is also improving. Musk stated that the Raptor 3 series, and by extension Raptor 4's vacuum variant, could reach a specific impulse of 380 seconds, enabled in part by an oversized nozzle optimized for performance in space. With Raptor 3 already achieving a record-setting chamber pressure of 350 bar, Raptor 4 is expected to exceed even that, solidifying SpaceX's lead in engine performance. In terms of design evolution, the Raptor engine has also been getting lighter. Raptor Ver1 weighed around 2,000 kilograms, V2 dropped to 1,600 kilograms, and it is estimated that Raptor Ver4 may weigh close to 1,500 kilograms. When paired with a thrust of 330 tons of force, this results in a thrust-to-weight ratio, TWR, of roughly 220, substantially higher than the Merlin 1D's TWR of 180. This metric is critical, as a higher TWR indicates greater efficiency and acceleration potential. In this context, Raptor 4 not only surpasses its predecessors, but also stands out as one of the most advanced and capable rocket engines ever developed. SpaceX has several engineering options to achieve the increased power seen in engines like Raptor 4. One approach is to enlarge the nozzle while keeping the flow rate, chamber pressure, and throat area constant. This modification can improve specific impulse, making the engine more fuel efficient and potentially increasing thrust slightly. However, a larger nozzle adds weight and expands the engine's footprint, which may complicate fitting all 33 engines into the Super Heavy booster's base. Another method to enhance performance involves adjusting the throat size while keeping the nozzle and chamber pressure unchanged. Reducing the throat diameter can lead to higher exhaust velocity, improved specific impulse, and a better thrust-to-weight ratio. The trade-off is a reduction in flow rate, which can lower total thrust output. The most promising and technically challenging path, which SpaceX is actively pursuing, is increasing chamber pressure. Higher chamber pressure directly results in a greater thrust-to-weight ratio, which is crucial for improving overall vehicle performance. However, this also raises the temperature inside the combustion chamber to levels that can potentially damage or melt engine components. To overcome this, SpaceX is experimenting with advanced materials, custom alloys, and improved cooling methods to ensure durability under extreme conditions. But why does SpaceX need the immense power of Raptor 4? At first glance, it might seem a bit overkill. The current Raptor 3 engine is already at the cutting edge of high-performance rocket propulsion. It is powerful, efficient, and fully capable of supporting Starship's existing goals. So why push further? The answer lies in SpaceX's long-term vision, specifically its plans for Mars. According to the latest roadmap, by 2033, SpaceX aims to send 500 Starship landers to Mars. These ships will deliver mining equipment and infrastructure essential to building a self-sustaining presence on the Red Planet. Each Starship lander is expected to carry up to 300 tons of payload, an enormous mass that demands significantly more thrust than what current Raptor engines can reliably provide. That is where the next-generation Raptor 4 comes in. But there is more to it than just raw lifting power. Higher thrust also opens up greater opportunities to exploit the Oberth effect, a fundamental principle in astronautics. The Oberth maneuver involves firing a rocket's engines at the lowest point in its orbit when it is moving fastest through a gravitational well. Because kinetic energy increases with the square of velocity, burning fuel at higher speeds yields much greater energy efficiency. In practical terms, this means that a powerful, high-thrust engine like Raptor 4 allows Starship to perform high-efficiency orbital burns during planetary transfers. That is especially critical for deep space missions, where every kilogram of fuel saved increases the total deliverable mass or extends mission flexibility. The Oberth effect is named after Hermann Oberth, a pioneering physicist in rocketry who first described it in 1927. It is most effective when a spacecraft can deliver maximum impulse in a very short time, something only high-thrust engines like Raptor 4 can achieve. So while Raptor 3 is already a technological marvel, Raptor 4 is about scaling up to make interplanetary logistics, high-efficiency maneuvers, and full-scale Mars colonization feasible. Another major reason SpaceX is developing Raptor 4 is to reduce costs. Elon Musk has consistently emphasized his goal of making rocket engines as affordable as possible. At one point, he stated that the target cost for a Raptor engine is less than $250,000. While that remains a highly ambitious target, it is not entirely out of reach in the long term. Currently, the cost of raw materials alone, particularly high-nickel alloys used in combustion chambers and nozzles, can approach $100,000 per engine. In addition, components like engine controllers, pressure transducers, and rotational sensors are expensive, especially when designed to operate under extreme conditions such as cryogenic temperatures and high pressures. These components also require rigorous testing and qualification, further driving up costs. Automation will help reduce labor expenses, but it does not eliminate them entirely. In many ways, automation simply transfers labor into the design, production, and maintenance of machines. What truly brings down manufacturing costs is high production volume. Raptor 4 is expected to have a more streamlined and simplified design compared to its predecessors. More parts will be integrated into single assemblies, reducing the number of joints, bolts, and failure points. It will also be built to be more robust and reusable, allowing it to fly multiple times with minimal refurbishment, which further reduces cost per launch. While reaching the $250,000 mark may take time, it is not an impossible goal. In the near term, a more realistic price for Raptor 4 is estimated to be around $500,000 per engine, which would still represent a significant cost reduction over earlier models and a major step towards affordable spaceflight. Although Raptor 4 is still more of a rough concept than an actual engine, Elon Musk has been mentioning it since 2024. That suggests SpaceX might already be making early progress behind the scenes. So the big question is, when do you think SpaceX will unveil the first Raptor 4 prototype? Will it be in 2026 or 2027, or could it even happen by the end of this year? Drop your prediction in the comments below. While Raptor 4 is still a topic for future discussion, there's one engine we'll almost certainly see fly later this year, the Raptor 3. Elon Musk recently gave an update during a speech at Starbase, where he shared an impressive video of the new engine. According to the video, SpaceX has already tested over 300 Raptor 3 engines, accumulating more than 16,000 seconds of total runtime. That's a serious milestone. One of the most striking things about Raptor 3 is its radical design simplicity. It has virtually no visible pipes, hoses, or wires. It looks almost too clean to be real. Musk even described it as alien technology. This minimalist design allows SpaceX to eliminate the external heat shielding usually required to protect vulnerable components. With nothing exposed to burn or overheating, the engines can hang openly. This reduces weight and increases payload capacity. But the benefits don't stop there. The cleaner design also removes closed-off areas where excess fuel and oxygen could accumulate and potentially explode. While this hasn't been a major issue for the booster stage, it's been a significant challenge for the Starship upper stage. If Raptor 3 solves that, it could be the key to finally allowing Starship to survive re-entry and complete full mission profiles, which has been a major hurdle in its development so far. Speaking of new engines, Russia has one of its own. Recently, Rosatom, Russia's state-owned nuclear corporation, unveiled a prototype plasma rocket engine, a technology it claims could drastically shorten space travel times. The laboratory model, which uses a magnetic plasma accelerator, generates at least 6 newtons of thrust with a specific impulse of over 100 kilometers per second. For perspective, 6 newtons is about the force needed to hold a small apple against gravity. While modest compared to the explosive force of chemical rockets, plasma engines work differently. They operate continuously over long durations, gradually accelerating spacecraft to very high velocities. Plasma engines are a form of electric propulsion. Rather than burning fuel, they ionize gas and use electromagnetic fields to accelerate the charged particles, generating thrust. This makes them far more efficient than chemical rockets, allowing spacecraft to travel farther using significantly less fuel. Rosatom's prototype operates in pulsed mode, delivering an average power output of 300 kilowatts. That level of energy could enable travel to Mars in just 30 to 60 days, compared to the current 9 to 12 months. Such a reduction in transit time would limit astronauts' exposure to cosmic radiation and other deep space risks. The project is part of Russia's new Nuclear and Energy Technologies Initiative, launched in 2025 to drive national technological leadership. A dedicated testing facility has already been established in Troitsk, equipped with a 14-meter-long vacuum chamber for simulating space-like conditions and testing the engine in realistic scenarios. Rosatom's push into space propulsion aligns with its broader strategy to expand nuclear technology and space exploration. The company is also developing nuclear power systems for spacecraft, including solutions for transport missions, research, and even planetary surface operations. Rosatom's nuclear space technologies were initially developed under the Development of Technology and Scientific Research in the Field of Atomic Energy Use program, which was launched in 2021. This initiative supported advancements in nuclear materials, power systems, fusion research, and more. In 2025, it was integrated into the broader New Nuclear and Energy Technologies national project, reflecting Russia's strategic push to maintain technological sovereignty and gain a competitive edge in high-tech industries. If you have watched this far, I truly appreciate your time and interest. I am glad to know that this video has been helpful to you. We are on our way to reaching our goal of 20,000 subscribers, so feel free to support us by hitting that subscribe button. It really helps a lot. Thank you.